Hello guys, and welcome back to the CCNA video series brought to you by ABY Design and Tech. In this video, we're going to find out how private and public IP addressing saved the IP protocol. So the learning objectives for this video will be to understand what public and private IP addresses are, to understand why we need public and private IP addresses, and to understand the issues that private IP addresses resolve. So before we talk about public IP addresses, private IP addresses, we have to go back in time. More specifically, we have to go back to the 1980s and 1990s. So, the original designers of the internet, their plan was that any device which connects to the internet would be assigned a unique IP address which is routable over the internet. So, just to whiteboard how this used to work. Imagine me, Abda, starts up his own company. In this case, my company is called Company X. So I've got my own company. We start off relatively small with a single site. However, we start to expand. So imagine we've got multiple sites, all under the control of Company X. So I'm the entity which controls these sites. And obviously we've got all of our devices in these sites, our different branch sites, etc. So imagine we've got about 2,000-3,000 devices which need to connect to the internet. Being the owner of the company, it would be my job to go and purchase, say, internet connection. So I'd approach an ISP. I would say to the ISP, hey, look, I want to connect to the internet. Okay, I want to connect to this amazing thing, which is going to help me grow my business because I will be able to essentially communicate and talk with people across the entire world. My ISP would ask me my requirements. In this case, I would tell them this is how many devices, or this is the size of my company at the moment, 2,000 to 3,000 hosts. I expect to grow exponentially within the next 10-15 years. Based on that, let's say that they give me a Class B network. So they assign me a Class B network. In this case, it's going to be 172.16.0.0/16. So they assign me that network, and whilst I'm paying the ISP a certain fee, only I can use that network. Only I can use the IP addresses defined in that Class 4 network. Nobody else in the entire world can use those IP addresses. So I start to assign my devices IP addresses, everything's good, etc. And then more companies do this. So we have companies like Company B, Company Z, etc. They all want to connect to the internet. They all get assigned blocks of IP addresses, which, by the way, I would never, in this case, I wouldn't even be able to grow my company as large as to use all the IP addresses provided by Class B network. So we have tens of thousands wasted IP addresses, even more, millions of wasted IP addresses if you're assigned a Class A network. However, what the original designers of the internet did not expect is that the internet grew extremely large. It grew exponentially. So by the 80s and 90s, we were actually running out of IP addresses. That's right, we actually had an IP address shortage problem, in that we didn't have enough IP addresses to give every single device in the world a unique IP address. Now, something needed to be done. Because obviously, if we're running out of IP addresses in the 80s and 90s, how the hell are we still using IP addresses today? So the designers of IP, they thought, okay, we need to do something to extend the life of IP before we can create another layer 3 protocol which has got more addresses, known as IP version 6. So the IP that you're seeing here, that's known as IP version 4. There's another layer 3 protocol that the designers of IP created called IP version 6, which was the long-term solution to this addressing issue, in that it included many more addresses. But obviously, something needed to be done to essentially bridge IP version 4 to IP version 6. We needed something in place so that we had enough time to create this new protocol. Now, the solution to this problem was as follows. Let's take the IP address range and let's break it up into two groups. So we broke up our IP addresses into public IP addresses and private IP addresses. So public IP addresses are used for internet communication. They must be globally unique, which means that no two devices in the entire world can have the same public IP address. Now, the assignment of public IP addresses, that was controlled by some sort of global authority. As an example, the Internet Assigned Numbers Authority, they would hand down blocks of IP addresses to your regional internet registries, who would then assign them out to ISPs. And obviously, as a company, I would go to my ISP and they would assign me whichever IP addresses that they've been assigned. Now, private IP addresses. A private IP address is used within your local enterprise network for local communication. So that means, as an example, I started my company X, I could assign my devices private IP addresses. Now, it's important to understand that with private IP addresses, they're locally unique, which means that two devices in the same company cannot have the same private IP address. However, if I start company X and I assign, let's say, as an example, a device in my company, I've assigned an IP address 192.168.1.1, that's a private IP address, then that means a device in another company, Company Z, could use the exact same IP address. And the reason being is because those are private networks. As long as nobody else in my enterprise network has got the same private IP address as another device, then that's fine. However, the drawback of private IP addresses is that they're not routable over the internet. That means that if I assign my device a private IP address, I can't use it to communicate over the internet. In fact, if an internet router receives a packet with either a source private IP address or a destination private IP address, it's going to drop that packet. Now, the assignment of private IP addresses, that is going to be controlled by the network engineer for that company. It would be the network engineer who decides what private IP addresses you guys are going to use and how to assign them out to different devices. The third step for this solution was NAT, Network Address Translation. That translated private IP addresses into public IP addresses. So, the next question you guys probably have is, Abda, what IP addresses are private and what IP addresses are public? So, the private IP address range is as follows. Class A addresses within this range 10.0.0.0 through 10.255.255.255 are all private use only. So that's one Class A network. Class B addresses between 172.16.0.0 through 172.31.255.255 are reserved for private use only. So that's Class B. 16 Class B networks reserved for private use only. Class C, 192.168.0.0 through 192.168.255.255 reserved for private use only. So that's 256 Class C networks. Now, it's important to note that why haven't I listed any public IP address ranges here? Because anything outside of these three ranges are going to be for public use. So that means I cannot use these IP addresses to communicate over the internet. If I have a device with this IP address and I try to communicate over the internet, first of all, my packet won't really go anywhere. And second of all, even if it does manage to get out to the internet routers are going to drop that traffic. So to understand how these three technologies, essentially these three concepts, saved the IP protocol, because obviously we had our IP address shortage back in the 80s and 90s. How the hell are we still using IP addresses today? So this is how the story goes, and then we're going to whiteboard this. So instead of every device having a unique IP address, like how it was originally planned for it to work, a company would just use the private addressing inside the enterprise network. So that means company X, my company, I would just pick one of the private networks, either it's going to be Class A, B, or C, and I would use those IP addresses to give my devices inside of my network an IP address. Company Z may do the same thing. And the beauty is that those ranges for Class A, B, and C, we could have multiple companies, in fact we do have multiple companies using the same private address ranges because it doesn't matter. We don't have any insight to that because when they communicate over the internet, which is what is important, they will be using public IP addresses. So again, this would allow devices within the same enterprise network, within company X, within company Z, where it would allow those devices to communicate. And again, because private addressing is locally unique, it means that multiple companies, they can use the same IP addresses within their private network. That's fine. And no one will ever see that because that's their private network. I don't have any visibility to that. The company will then purchase, depending on their requirements, depending on the size of the company, they may purchase a single IP address or a range of public IP addresses. Again, this would be purchased from your ISP, and your ISP, essentially, you would go to your ISP and be like, I want to connect to the internet. They would then offer you a couple of IP addresses or a single IP address from the range that they've been given. Now, once we've done that, Okay, you're thinking, Abda, okay, my devices have got private IP addresses, they can communicate locally with each other, great, but they still can't communicate over the internet. And if I only have 1 or 2 public IP addresses, does that mean that only 1 or 2 of my devices can communicate over the internet? Well, fortunately for us, this is when network address translation comes into play. So, when communicating to a device on the internet, your traffic obviously would flow to your edge router. So your edge router is the router which sits on the edge of your network and connects you to the internet. So essentially this would connect to the ISP's router and would be internet circuit. Your traffic is going to flow to your edge router. Now, before your router sends your packet out onto the internet, it can't send it as it is because it's got a private IP address and that's just going to be dropped. It actually changes the private IP address into one of the public IP addresses or the single public IP address that you have purchased. That's when that does. Network address translation changes private IP addresses into public IP addresses. What does this mean? This means that your traffic can be routed over the internet fine, and it allows you to hide all of your devices behind this single IP address. Because you've purchased this public IP address from your ISP, everybody in the internet knows that, okay, public IP address 1.1.1.1, that's associated with company X. So if I ever receive traffic sourced from 1.1.1.1, I'm going to send that back to company X. Now, when the traffic flows back to your edge router, guess what he does? He just translates the public IP address, in this case 1.1.1.1, to the private IP address of the device which originally sent that packet. Now, this is very powerful because that means that we can use private IP addresses within an enterprise network and we can represent our entire company with just 1, 2, 3, etc., a couple or a few public IP addresses. Hence, not every single device in the internet now needs to have a unique IP address. Now, to see how this works, let me just whiteboard this out. So again, we're going to go back to our original example that we used, in that my name's Abda, I start off my company X. So this is company X, and again I'm going to draw all the devices under my control. So we've got our different sites, etc. That could be some of our branch sites. We have a headquarters sign. Obviously at each site is going to have their own sort of devices. So we've got some devices over here, we've got some devices over here at this site, etc. Some devices over here as well, and our sites are all connected together with point-to-point leased lines. Okay, now as the network engineer, Billy decides that, okay, we're going to use private IP address range 172.16.0.0. Okay, now this is a private IP address range. Obviously, when I did the example earlier, that would have been a public IP address range before private addressing came to fruition. So that means I will start to assign my devices IP addresses from the address range. So IP addresses like this, like that, etc. Imagine this is Bob. So Bob is assigned IP address .10. So 172.16.0.10. And we have my edge router over here. Now, I want to connect to the internet because I've heard that it's this amazing thing. And it will be great for my business because I'll be able to get in touch with people across the entire globe. So I approach my ISP, this is the internet over here, and I'm like to my ISP, okay, I want to purchase some public IP addresses so I can now communicate over the internet. And obviously this public IP address assigned to me, nobody else in the entire world can have that same public IP address. So I tell him my requirements. He says, okay, for you, I'm going to give you one public IP address. In this case, it's going to be 217.35.1.1. Okay, and that that public IP address, so this is my connection to the internet, etc. My public IP address is going to be assigned to my internet facing interface on my router. So this is the interface on my router. Imagine it's interface FA. Let's just put 0/1. I assign that public IP address to that interface, and on the other side, my ISP is using 217.35.1.2. Okay, all great. Now, when Bob wants to communicate over the internet, imagine he wants to communicate with, let's say, Amazon up here. So we're going to put Amazon up here. His traffic is going to flow like this. So it's going to flow all around our network, go to the edge router over here. Now, when the edge router receives it, he can't send out as it is because private IP addresses cannot be routed over the internet. And even if he did send it, these guys, the internet routers, wouldn't know how to get back to 172.16. anything because they don't have a route for that network in their routing table. So our edge router does something very clever. So let's just call this R1. So R1 does something very clever. He takes Bob's IP packet. Okay, imagine this is a source IP address field, and he changes Bob's 172.16.10 IP address into our public IP address. At the same time, he also creates a translation entry. So it's essentially in the router's memory, he keeps what's called a NAT table. And in his table, he's saying that I've just translated Bob's IP address 172.16.0.10 into this public IP address. I can now send that traffic over the internet. It gets routed all the way to Amazon. Amazon, when they respond to me, know how to get the traffic back to company X. The reason being is because everybody in the internet knows that the public IP address 217.35.1.1 is used to identify and is used by company X. So the traffic goes all the way over the internet back to me. When it hits R1, R1 looks in the NAT translation table and sees if I receive any traffic from Amazon going to the IP address 217.35.1.1, I'm going to translate the public IP address. Now that's going to be the destination. I'm going to translate the destination IP address back into 172.16.0.10 and then send that traffic all the way back to Bob. And see, this is the power of private addressing, public addressing, and NAT. With private addressing, I can give all my devices in my enterprise network a unique IP address within that enterprise network. That means that we can have companies across the entire world and houses as well across the entire world using the same IP addresses. However, when they go out on the internet, they use the public IP address which has been assigned to them. And the beauty about NAT is that with NAT, we can support our entire enterprise network, our entire company's network using a single IP address. So now, all of our devices hide behind this single public IP address. To Amazon, they're just seeing the traffic coming from 217.35.1.1. They didn't even know who sent it. They don't know that it's Bob who sent it, and Bob's got this actual IP address. They just see this traffic coming from 217.35.1.1, and they're going to send that traffic back. So as you can see, instead of a device not having a individual IP address, a unique IP address in the world, we can use private addressing. All the devices across the entire world can have the same IP addresses. However, when we go onto the internet, then we hide behind the public IP addresses that have been assigned to us. And that way, we can still have communication over the internet because the public IP addresses we're using are going to be unique to us. So guys, that's public and private IP addresses explained. Again, with this concept, I like to explain it as a story because then it just makes sense. As you can see, with public IP addresses, was before the invention of public and private IP addressing, we almost ran out of IP addresses. However, with public and private IP addresses, as well as NAT, we were able to save the IP address space because we were able to now represent thousands of hosts behind a single public IP address. And with NAT, there's a lot more to NAT and there's different types of NAT. I will explain that in another video, but for now, just know that with NAT, we can translate private into public IP addresses, and we can essentially represent thousands of hosts with a single public IP address out on the internet. So essentially, we're hiding our network behind this public IP address. They only see this public IP address, they don't see our actual network. Now, there's another technology or another concept combined with this which helped save the IP address space, and that's subnetting. And in the next video we'll talk about subnetting and what it is. So guys, if you found this video useful and you would like to see more content like this, then please subscribe to my channel, and thank you very much for watching.